Hello everyone. Today we are going to discuss about 3n+1 problem, which is a mathematical problem which has some mysterious place. I am Monica Chaure and I am diving into this problem with you. So let's move forward. Introduction to 3n+1 problem. So what is the 3n+1 problem? The problem is proposed by Lothar Collatz in 1937. Even though the rule is extremely simple, it's been unsolved for decades. It's been unsolved for decades. That's what makes it so fascinating. It's easy to understand but incredibly hard to prove. This is the short introduction about 3n+1 problem. We are now discussing about the problem statement. Here is how it works. You so start with n, which is an integer. If the n is even, divide it by 2, or if it is odd, then divide by 3 and add 1. Repeat this process up to you will reach 1. This is the problem statement. Let's now we discuss about the example of 3n+1. Let's take one number that is 6. The string our problem start with a 6 integer. 6 is an even integer. So divide it by 2. We get 3. 3 is an odd integer. Add 3, multiply it by 3 and add 1 in it, we get 10. 10 is even, divide by 2, we get 5. Repeat the process up to we get 1. This is the simple example of 3n+1. Now we will discuss about the characteristics. The 3n+1 applies to every positive integer. No number tested so far has failed to reach 1. Even number larger than 2 to the power of 60. But here is the catch, we still don't have a general proof that it works for all numbers. These are the some key characteristics. Why is it important? Why do we care about this problem? Because it shows how simple rules can lead to very complex behavior. It's linked to number theory, Chow's theory, and computation, and it highlights limitation of current mathematical methods. Now we will discuss about the current status of the problem. So where do we stand today? Well, it's still an open problem. No one has found a proof and no one has found a number that breaks the rule. It's considered deceptive simple, so simple that some wonder how it's still unsolved. This is the current status of the 3n+1 problem. Now we will diving into the applications and implications of the our problem. Even though it's unsolved, the 3n+1 problem is useful. It's a great way to teach algorithm thinking and recursion. It also connects to iterative functions and discrete dynamical systems, which appear in fields like computer science, physics, and biology. Now we will discuss about the challenges in solving 3n+1 problem. So why is it so hard to solve? Mainly because the sequence behaves so unpredictable. Some go up really high before something down. There is no clear mathematical structure. Solving it might require entirely new tool in number theory. That's why there are some challenges to solve this problem. Start with any positive integer x. If x is even, divide it by 2. If x is odd, multiply it by 3 and add 1. Repeat the process until you reach 1. So this is our problem statement which we have discussed earlier. Now we will explain the code for this problem. So take Collat's sequence of x, define a function name that takes input as a x. Num sequence equal to x, list with the starting number x, num sequence will store the entire sequence. If x is less than 1, it it return empty list, or file x is greater than 1, we have to divide x by, for checking that x is even, we divide x by 2, we get x modulus 2 equal to 0. Then we, if the our x is 2, divide the x by 2, else x, x is odd, then multiply it by 3 plus 1, then append the sequence into the x, and then return the number of sequence. Print collage sequence 12. Let's follow the step for x equal to 12. Here 12 means the x. So now we run the program, we will get an output. This is the simplest output of our program, which we discussed earlier. It's all about the 3n plus 1 problem. Thank you so much. If you have any doubt, please comment. Thank you.